Focal length and optical power. The focal length of the lens is the distance between the lens and the point that all parallel rays of light converge into a single point, and this point known as the focal length. So let's say we have a lens, radius of curvature R1 for this side, R2 for the other side. The thickness is D. So as I mentioned before, we discussed it, the focal length is equal to n minus 1, n is the refractive index of the lens, 1 over R1, the radius of curvature of this surface, minus 1 over R2, the radius of curvature of this surface, plus n minus 1, again n is the refractive index, times distance over n R1 R2. So if we put all values into this equation, we can get the focal length, which is the distance from the lens to the focus point or focal point. We have another concept that we call it optical power. So it's not related to the optical power in milliwatt or that kind of stuff. This kind of optical power is the ability of the lens or mirror or any optical system to converge or diverge light. So it's not related to the actual physical energy of light, nothing related to that. This is just related to the ability of the lens to focus light. And we have different names for optical power. Sometimes we call it dioptric power, refractive power, focusing power, or convergence power. Those are some different names for the optical power. But generally, any optical system that can converge light more, we can say it has higher refractive index. So now let's look at different lenses. We have 4 kinds of lenses. The first one is a lens that has two convex surfaces. We have another lens, but the radius of curvature is smaller. We have a lens that has 2 concave surfaces, or negative radius of curvature, and a flat piece of glass. Now let's look at the ability to converge the light. So for the first lens, you can see it has a high optical power, so it can converge the light very quickly, very close to the lens. So for this lens, the focal length is pretty small, so the optical power is higher. But for this lens, also has optical power, but the focal length is very high. I mean higher than this one. So it means that this lens has less optical power compared to this one lens. And this lens also has optical power, but the optical power is negative, because if you continue those lines, they converge somewhere here. So this lens actually is diverging. So for a lens that is diverging light, we can say it has a negative optical power. And for this piece of glass or window, the optical power is 0. So let's review again. This lens has a positive optical power. This one also has positive optical power. But this lens has much higher optical power compared to this lens. This lens has negative optical power. And this piece of glass, this window, has 0 optical power. So we should keep in mind the relationship between the optical power and focal length. They have a inverse relationship. So sometimes we use P for optical power. P is equal to 1 over F, or sometimes we use capital F. So we should be very careful. We should not mix these two parameters, capital F and lowercase f. So capital F is equal to 1 over F, or P is equal to 1 over F. The unit of optical power is diopter, which is 1 over meter. So usually for focal lens, use centimeter or millimeter. Let's say a lens has 20 millimeter focal length. But for optical power, we use 1 over meter. Now let's look at some examples. For example, you can see for this lens has a high optical power. So this lens, the optical power is 1 diopter. So it means that the focal length is 1 over 1 diopter, which is 1. So the focal length is 1 meter. If you put 1 over 1 meter is equal to 1 diopter. The focal length of this lens is half a meter. So 1 over half a meter is 2 diopter. The focal length of this lens is 2 meter. 1 over 2 is equal to 1/2 diopter. The focal length of this lens is -1 because it's actually diverging the light in this direction but converging the light in this virtual point. The focal length is 1 over -1, so the optical power is -1. The focal length of this lens is 1/2, -1/2, so the optical power is -2 diopter. So whenever we see the optical power in diopter, we should quickly change it to the focal length and guess where is the focal length of the lens.